Hello everyone. Today's session starts with the security attacks, data breaches, and ontologies. In this security attacks, data breaches, and ontologies, the first topic which is fraud detection and prevention. In a fraud detection and the prevention, in this process of identifying some suspicious or illegal activities in a system, especially in financial transaction, maybe a transaction declined or something which is happened by the user, and someone may be stolen the amount or some other thing will be happened in the fraudulent in a financial transaction. In these ontologies in cyber security are having some structured and machine interpretable frameworks that define the concepts and relationship and rules within the security domain. Based on the security domain only we are providing the fraud detections, and we are using some prevention system like a financial transaction and some other cases. So here the role of ontologies in a fraud detection. In these ontologies, it transform a raw data. So whatever the raw data the user they want to access, so this raw data into a structured knowledge base, allowing a system to reason about the relationship between the user's actions and devices. Suppose I may be the user, so how I have handled with my raw data within the system, which means how the relationship between the user as well as the action or the trigger may be used by the user in between the devices. So number one, the behavior modeling and anomaly detection. So here the ontologist models user behavior like a login time, maybe a login time. Suppose we are having a login time failed out like that, then location where the user may be login, that particular user login, and the transaction type, what kind of transaction type the user using for this kind of ontologies. So these deviations from these baselines are detected as outlier to identifying some potential account taker, which is called ATO, or some unauthorized access. Then the second one, some semantic data analytics. Unlike some traditional signature based detection, semantic approaches can identify variations of an risk or attack by understanding the context and relationship rather than just the syntax. So that is the semantic data analysis. And the next one, intelligent fraud rules. Some ontologies enable the creations of intelligent rules. For example, using different types of query, okay, like Jena, Sparkle. So these all are some query engines that can be infer hidden relationship in financial transactions such as money laundering or some other things. Okay, so this is called intelligent fraud rules. And the fourth one, which is the real-time detection and prevention. Some ontological frameworks we can easily analyze the transaction in a real world time to detect some suspicious activities before they fully materialize. For example, some multi-factor authentication. We can use different kinds of multi-factor authentication like face recognition, like otherwise finger, some other physical factor authentication. Some encryption techniques, we can use different kinds of encryption technique as well as different types of transaction monitoring system as well as the secure payment gateway. So these all are some prevention method for real-time detection and the prevention. So ontologies for security attacks and data breach preventions. It helps to map the entire life cycle of a breach. Maybe different kinds of breaches are available. So the entire breach will be mapped from initial access to the data exfiltration. The first one, security attack modeling. In the security attack modeling, which is called stack, shortly we can denote it as stack, the security toolbox we are using with different security toolbox, the attacks and countermeasures like STAC. Ontology helps non-experts understand complex attacks and mapping the relationship between different assets, vulnerability as well as different kinds of threats. And suppose we are using different network vulnerability analysis. So using this kind of vulnerability analysis, some ontological attack graphs analysis, possible paths an attacker may take to compromise different network, identifying weak points and enabling some proactive patching. So this is the network vulnerability analysis. Then the third one, which is called the third party APIs security. During the year 2025, in this trends, third party breaches like Salesforce or Salesloft or Snowflake, So these all are some dominant. So ontologies map third-party access, identifying over permission API keys or some weak OAuth tokens. Okay, so this is third-party API speak. And the last one, AI and ML threats, like ontologies are used to different kinds of combat adversary like ML threats such as data poisoning or evasion attack by modeling the security of machine learning models using with different machine learning models. We are facing with different kinds of ontologies with AI and ML threats. And this is the framework for key ontological framework in cybersecurity. The Unified Cybersecurity Ontology, that is UCO, which integrates standards like SDIX or TAXI to the share cyber threat intelligence across all the platforms. So and the next one, Mitre, ATTCK and Atlas, which is not a pure ontologist. They are frequently converted into semantic representation like OW or RDF to enable automated reasoning over tactics or techniques and some other procedures. So next we are dealing with the credit card fraud. Okay, so before this one, there are some ontological serves, some structured knowledges models that organize some concepts, entities, and relationships to detect fraud by enabling semantic reasoning, data integration, and clear rule definitions. In this core function, we are having some fraud detection. So what are the fraud detections? Like a data integration. So these all are one core function when we are using with fraud detection. Then semantic reasoning, then behavior profiling. Then the benefits over this traditional system, we can get a clear explanation as well as the flexibility. So the clear explanation which provides the transparent rule-based logic that shows why a transaction was flagged, unlike black box machine learning models. Okay, then the flexibility of this benefits over traditional system. It adapts easily how the user can use new types of fraud emerge by simply updating the conceptual rules. Other is a relationship in the knowledge graph. And the next one, dealing with some credit card fraud. So in this ontology based system, it improves fraud detection by focusing on behavior patterns rather than just transaction volume, or some often achieving high precision like 89.4% of specific studies while reducing computational overhead. So we are using some semantic data modeling like is ontologies like different relationship like a card holder or merchant or location or behavior. So all these things in a graph structure allowing the system to understand the context of a transaction, what kind of transaction, whether the user can transfer the money from one to another, so otherwise the user can withdraw the money from a particular place like a location, otherwise the user can use that amount for a merchant or the card holders behavior. Like that, these ontologies models like the data relationship we can find out in the semantic data modeling. Then the outlier mining, these ontology graphs help identify some fraudulent reduction by detecting deviations from established some legitimate user behavior patterns, like which is called some outlier mining. So ontology graphs which is helps to identify the fraudulent transaction. Maybe the transaction may be a fraudulent hacker, otherwise some other people, a third party, may be stolen, or detecting some deviations from this kind of legitimate user. Then real-time detection, by comparing a new transaction only to similar patterns in the ontology graph rather than all past data system can detect fraud in real time, minimizing some potential loss. And the next one, semantic web rule language, that is SWRL rules, are used within these ontologies to infer new knowledge from predefined security rules about some suspicious activity. So these are the types of credit card fraud, like card not present, online fraud. Then we can the different kinds of skimmer machines they have used to skimming that particular credit card. Then phishing attacks and identifying these are the different types of credit card fraudulent. So the detection technique, how we are finding out this kind of detection technique, like a rule-based system. For example, there is a flag may be raised when the transaction is above 50,000 rupees. So this may be we can set by a user, otherwise the particular organization maybe set a flag for the transaction over 50,000. Likewise, then we can use different kinds of machine learning models. Like a machine learning model, the user can classifying with different kinds of classification algorithm like decision tree or neural network. Based on this, we can detect some unusual spending patterns. Suppose the user can be use this kind of credit card like this time to this time, otherwise for this particular transaction, otherwise that particular amount only can be transaction between these days. So that is the machine learning model we can use in different types of classification algorithm. Then behavioral analysis we can use with different track like location, spending habit, like device usage. So likewise we can track that particular behavior. Suppose where I have to using, where I have to use, like the location may be find out. Then the spending habit, why I am using, otherwise why I have to spend that particular card, otherwise then device is which device the particular card, otherwise the particular account may be used. Okay, so the real-time monitoring, it immediate alerts for a suspicious transaction. Suppose I am having a account, suppose my account may be hacked by someone, so automatically I can get some alert for a suspicious transaction. Then immediately the user maybe get some alert from this kind of fraudulent detection. So the next one, intrusion detection ontology. There are different types of intrusion detection ontology. Number one, there are that is called a security attack. There are two different types of security attacks. Number one, passive attack, and the second one which is called the active attack. In this passive attack, which monitors data without alerting it, for example eavesdropping, for monitoring a data without alerting. So we cannot get any alerting, but we can easily monitoring by the third party people. So active attacks to modify or damage your system. So automatically your system or your data must be damaged. For example, we can use different kinds of malware, or use different kinds of phishing techniques or denial of service. So this is the example for active attacks. The data breaches. So the data breach occurs when a sensitive information is exposed or stolen. Suppose I am keeping my data as a sensitive one. So this kind of sensitive information may be some kind of third party may be stolen this kind of sensitive information, or this kind of information may be exposed. So there are different cases may be available for this kind of reason, like a weak authentication. Suppose I may be given a weak password, otherwise the software vulnerability or insider that may be some insider threat available. Maybe the insider threat may be happen inside my system or some other thing. So the effect of these kind of data breaches, some financial losses, maybe I may get a financial loss, some theft identification, or some legal penalties maybe. Maybe the legal penalties may be faced by that third party. So these all are different effects when we are facing the data breaches. Then this is intrusion detection ontology. So there is simply implemented in, there are two types. One is not, and another one is called Swift-Kata. So here there is a models like ontology in intrusion detection. So here we are having some formal knowledge model that defines types of attack, system components, and the relationship between threats and behavior. So this helps to understand, detects, and respond to attack this kind of intelligently.